All right, I want to welcome everybody to session 2 of the workshop. I'm Dr. Nicole Hutton. I'll be the facilitator in the main room throughout the workshop. I'm pleased to welcome you back on behalf of the NASA UNBOUND Coastal Issues team. We're going to hold for just a couple of minutes for a few remaining participants. Thank you for your patience, and we will get started soon. I have 10:02. So there may still be a few people that trickle in the next few minutes, but to respect your time, we're going to go ahead and get started. So for those of you that just joined, I'm Dr. Nicole Hutton and I will be your facilitator in the main room today and throughout the workshop. I am pleased to welcome you on behalf of the NASA UNBOUND Coastal Issues team to day 2 of our workshop. I want to give just a brief reminder about the purpose of this set of workshops, which is reaching greater potential of NASA data through collaboration between NASA data scientists and analysis and visualization practitioners in targeted communities. Our workshop will introduce some of the NASA data and tools available to support mitigation and resilience planning efforts. Also, a reminder of the documents available to you, a participant's guide, and our interactive Google Drive for the day. Links were sent to you in email, and Blake is going to post them in the chat for us right now. If you'll keep that participant guide open throughout today, that would be helpful. We ask that you put any questions either in there or in the chat. We will be monitoring both and responding to both throughout the day. We, as always, want to acknowledge our funder. So we thank the NASA UNBOUND team, which we introduced in a longer description yesterday, for supporting this set of workshops. And we want to flag that any opinions expressed here are not necessarily associated with NASA's opinions. Right. The purpose of today's workshop is to understand sea level rise and NASA resources, including the associated science, applications, and data. We will focus on the NASA sea level rise and wetland change, as well as NASA flooding analysis tool, interagency SLR tool, IPCC AR6 tool, SLR eval and assessment tool, and the flooding days projection tool. We are very pleased to have representation from 5 continents in the UNBOUND CI workshop series. We've put this map together so that you can see where your fellow participants are joining us from. And just a reminder of and thanks to our UNBOUND CI team from ODU and Virginia Tech, as well as our note takers and IT team that are not pictured. You will interact with many of these individuals in the breakout sessions later today. A brief reminder of the ground rules. Facilitators will be in the main session and breakout rooms to ensure things run smoothly. If there are any technical issues, questions, or comments for us, the speakers, or each other, please place those in the Google Doc. We will be monitoring that throughout the session. Keep in mind that there are no right or wrong answers. We are here to learn from you as much as we are to present information to you. We welcome you to share your experiences accessing and using NASA data, including your successes, frustrations, and your ideas for improvement throughout the workshop, from the smallest thing to the big ticket items. I would like to introduce our first demonstration speaker today. Our speakers will be time limited. Reminders will be placed in the chat and shown on the screen as each speaker approaches 5, 2, 1, and 0 minutes before I interrupt them to keep the session on time in respect for both their input and your time. At this time, Keith Van Fieldlen from Esri will present for 15 minutes. Keith is a product engineer with Esri in Redlands, California. He serves as the ocean curator for the Living Atlas of the World, a long-term project whose emphasis is on visually appealing and useful map information products. He works with members of the marine community to curate contributions and build the GIS of the world. If you would start screen sharing, Keith, and get started when you're ready, we are ready for you.
Let me jump in. Sorry, this is George. I've known Keith for a long time, and I didn't preface Nicole that Keith is also ODU alum, and we're very proud of that. And his last name is Van Graffelen, which is only slightly harder to pronounce than my last name. So I just wanted to give everybody a heads up on that. Keith Van Graffelen is one of our former stars at ODU and now doing great things at Esri. So anyway, thanks again. Take it away, Keith.
Yeah, thanks, George, and thanks, Nicole, for the introduction. Can I get a quick thumbs up that you can hear me okay? All right, great, thank you. And my screen's coming through?
Yes.
All right, thanks. Well, it's great to be here today. As George and Nicole mentioned, my name's Keith Van Graffelen, and I am an Old Dominion alumni. I'm here today to talk to you about the ArcGIS Living Atlas of the World. So I'm here, I work for Esri, and I'm hoping that if you're not already familiar with the ArcGIS Living Atlas of the World, you'll walk away today knowing that this is a resource out there that you can utilize, and the relationship that we have with NASA in building, among other authoritative data providers, but in building this out, using their authoritative information and making it readily available to you. Here is my pretty picture and my email address if you'd like to get in touch with me following this, or with any questions you have about Esri, I can get you pointed in the right direction. But essentially, I work as the ocean content curator for the ArcGIS Living Atlas of the World. And what that means is working with authoritative data providers to make their data, their flagship products, available to the broader GIS community, and then interacting with the GIS community to understand what their data needs are. So these things can range anywhere from creating an ocean base map or any sort of base map that's used in your mapping efforts, or bringing in some real-time data that can help us understand the changing world around us and the phenomena of maybe sea surface temperature or even sea level rise. So happy to share some of this work with you today, and to hopefully broaden your horizons about what this Living Atlas is. So just in generic terms, we have a team within Esri that works on curating the content that comes into the Living Atlas of the World, and we receive these as nominations through the Living Atlas app. And we host some of that information ourselves. Sometimes Esri provides a value add to maybe translate some data or make some information a little bit more performant. But most of the time, those nominations are coming directly from contributors that are hosting their own content and nominating it through an app to where it shows up within the Living Atlas of the World, and then it's available to you in some of our clients like ArcGIS Pro or within a web map to where you can readily use these services, these layers in your maps and bring context to your work. So by contributing, by NASA being a contributor of data to the Living Atlas, it not only makes it easier to find, it provides value to users that are looking for something. It's kind of like the first place that people go to find ready to use GIS layers. So we like to think of the Living Atlas of the World as authoritative, curated, interoperable, updated, and growing on a daily basis. So we're actually getting new maps and layers added, every day that are coming from different authoritative data providers that are collecting information out there. And within the ArcGIS Living Atlas of the World, we've got a series of different themes. So we've got imagery, base maps, people, which is like the demographic data, boundaries, infrastructure, and then the team that I support is the environment team. And then within that, that broader theme, we've got these sub-themes. And the one that's most near and dear to my heart, and I think probably most of the people on the call today, is that oceans theme or sub-theme within the environment group. So we're going to hopefully dive in, no pun intended, to some of those layers and understand a little bit more about them. I keep mentioning these authoritative data providers, right? So these are people that they have a mission, right, within our government, within their work, in order to make data available to the community. And here's a list of those. And NASA is really kind of been, paving the way for a lot of these other agencies, particularly in the ocean. I've been doing a lot of work with them over the past 4 or 5 years. And we have bi-weekly meetings where each one of their DACs are talking about how they're standing up layers and how they're getting them within the ArcGIS ecosystem, and then how they plan on getting them nominated into the Living Atlas of the World. So they've got all these data centers that are spread out. They have different subjects or themes themselves, and then they're all working together to kind of shuffle their flagship layers into a GIS ready format, and then consequently into the Living Atlas of the World as well. And then what's exciting about that is there's a new pattern of GIS that's emerging from that, from what I just described, right? So where that work leaves off, right? So there's a whole team of people that are working just to make that content available to the community. We see users coming along and picking that up and doing outstanding work with it. So people start where someone's life work or someone's calling or day's work might have ended. So it's kind of this pattern of starting where others have finished. So making and staging that data and doing that complex work, making it available to you as a user, you can pick it up and do these things with it that people did never imagine or never even thought about. And we also have these live feeds in the Living Atlas as well. So we've got the world around us is changing. We've got sensors out there that help us understand what the temperature of the ocean is, what the water level is, at a certain water monitoring station, when a hurricane's coming. And these are used within our disaster response program. So these are things that we rely on. They have high performance and high availability within the ArcGIS Online environment. And here's some of the examples of those maps and layers that can help support the situational awareness. So kind of going back to what I mentioned earlier is making this content available adds to the level of exposure. So, you know, we used to have servers where you would publish things and it would be a REST endpoint. And people would have to try to go out and find where your server was in order to be able to add that layer to a map. And that's kind of what this little or excuse me, a gray circle is at the center here, ArcGIS server. So that's not really findable unless someone was maybe emailing you a link or maybe exposing that through a website. And then came along ArcGIS Online, and that's where you can publish these content items. You can tell people about how to use the layer, what it should be used for, where it comes from, how often it gets updated. And you can actually style something to where when somebody adds it to a map, it has a curated look and feel to it. When you click on that layer, it has a pop-up that's configured that tells you a little bit about it. And then the further you go down that path is you get into this ArcGIS Living Atlas, and that information has been curated. It's been actually looked at by someone within Esri before it gets accepted, and it goes through a whole entire nomination process. So there's a back and forth. It's kind of like a peer-reviewed article that gets accepted is what the way that we like to think about it. We like to consider this the top 1% of that information that's out there in ArcGIS Online that is most beneficial to the community. So we encourage people to get their content into the Living Atlas of the World, and that's where our relationship with NASA is. And an item is only good as a description, right? So here's a good example of an item that has a well thought out description. It tells people about the work that was done in order to create this underlying data set. It has references, it has hyperlinks, it lets people engage with that metadata to be able to find out more if they want to. And we have the ability to contribute. So within the application, and I'll show you here just momentarily, in the browser, you can look and see what's new in the Living Atlas of the World, but along the top ribbon here, we have the contribute button where someone can go, they can contribute their data to the Living Atlas of the World and go through that nomination process. And that's not Esri copying over NASA's layers. That's NASA nominating their layers to the Living Atlas. They still maintain control of it. If they want to update the underlying data, they're able to do that, and it trickles through to that end product that's in the Living Atlas. So right now, I just want to show a couple of ways that you can use data within the Living Atlas. So here is that Living Atlas of the World, and we can look for different sea level rise resources that show up here. So I think that's the topic for today and in this webinar. But we can see here the different sea level rise data sets that are out there. And these resources, much of which NASA contributed to within the Sea Level Rise Interagency report, are available. So we can look at that. We can click on the information and we can understand. So here we've got that good content item that we talked about, a nice description, and then we can begin to interact with this data within a map viewer. So here I see it's authoritative and it's in the Living Atlas. I can launch this and add that layer to a map. And what we have here are these US sea level rise projections for each of the different water level stations within the United States. And we can click on the pop-up and we can understand a sea level rise trend for the high scenario at this particular location. So it's a nice resource that we're able to see the pop-ups been configured, right? So it's not adding something with the default field list in there. It's got a nice graph in here. It tells you what you're looking at, and then has a meaningful display for these different stations. And then, so if I wanted to continue to add layers to my map, I can go to the Add button, I can browse for the layers, and I can go into the Living Atlas here and continue to build out that context to support my map. And then once I'm done, I can share that with my colleagues and put together a sea level rise map. And along those same lines, within ArcGIS Pro, users have the ability to go to the portal tab within within the ArcGIS Pro catalog, and then they can go over here to the Living Atlas tab and browse for those same resources. Look for sea level rise, and I can add some of these different resources in here as well. So here we go. Here's the gridded projections. So we were just looking at the water level stations. I can switch over my base map, and we can get a good idea of what these same projections look like. But these are those water level stations that we just looked at inform these gridded projections. And there's these for each one of the scenarios as well. And then the pop-ups are configured in order to provide something meaningful. So just a quick way to interact between a web map and ArcGIS Pro, use these different resources from the Living Atlas, and you know, how we're working with these different agencies in order to help collate this data for our community, for you. So with that, as a kind of a quick flyby, but I'm available to answer any questions if Nicole and George are good for it. But if not, I can throw my details back up on the screen and encourage you to reach out with me if you do have any questions. So let me pull that back up.
You do have a couple of minutes for questions today, so that would be great. Thank you for offering that to our audience, and thank you for your presentation.
Yeah.
All right, so if you are a participant and you have a question for Keith, please either put that in the chat so he can see it, or unmute yourself and ask that directly. We have a couple of minutes before our reflection activity where we have a question and answer period.
I'll throw a question at Keith because I know I've seen audiences ask this before. This is George. You show the Living Atlas of the World. Is there any special login, Keith, or requirement, a license or anything required to access that data?
I would say that, great question. 99% of the layers require no login. Anything that's coming from an authoritative data provider, it has to be public in order to be able to nominate that, right? But there are some Esri layers that are in the Living Atlas that are subscriber-based content. So this means that we have servers that are out there that are hosting some of this information. We put some value add in there, and it requires you to have a login to access that. That login doesn't, we're not, you're not using credits or consuming credits or anything like that with that. So it's just something that we feel is beneficial to the community to provide as a resource, and we require you to have a login for that.
Cool, thanks. Makes sense.
All right, guys, let me off the hook easy today.
Well, we will collect questions in the participant guide for you and share them with you if we get them so that we can get answers back to our participants. But thank you so much for your time. And if you do have a few minutes, we do have a reflection activity that we're asking our participants to do about your presentation. So in those few minutes when they have that, there might be questions that come up. I see one coming up in the chat now, perhaps. So I would like to direct our participants to the reflection activity. Blake has kindly posted that link in the chat, so please do open that up. I'm going to just share that screen briefly so that you know you have landed on the right page. So this is our page, and like yesterday, you can double click wherever you want, and that will put your comment wherever that click was. I see some of you joining now, so thank you for that. So we have a few minutes for you to go through that, or a few minutes for you to think of questions for Keith at the same time. All right, I see a couple of responses coming in here. Thank you so much. And I see a question in the chat for Keith. Are there vulnerability metrics available as a layer on the living atlas?
Let me see. I'll come back on video here. Great question. So that makes me kind of think about maybe the CRI, right? The coastal is it the Coastal Resiliency Index? I think it's what it is that's out there. There are some resources that are like that. There's also the one that comes from the short answer is yes, but we could use a lot more of that. We're seeing a lot of more organizations that are building out these indexes. The EPA uses one that's a vulnerability assessment when a natural disaster comes through, and they look at whether it's a long-term or a short-term natural disaster and what a community's response rate might be to that. And that's extremely helpful. But yeah, I'll dig that link up and I'll drop it in the chat. Great question. Was the graph social vulnerability index great? Yes, thank you, Amanda. You filled in my lack of vocabulary there. So yes, we do have a good social vulnerability index in there. Was the graph you had in the pop-up box live embedded? And if so, are there directions somewhere on how to do that? Yeah, what I did show was a live graphic, so you can configure the pop-ups, and maybe I can just show that real quick. Share my screen one more time, and so here is what we were looking at. Is that coming through okay? And when I click on the map, we get that pop up and you get these different values. Over here on the right-hand side, you have the ability to configure the pop-ups. And right here is a media, which is the line chart. And you can add the different content to it. So if I go in here, let's see, I can duplicate it. There's the title, there's the description, and you have the ability to kind of make it work off of the different data that's out there. So you can select the different fields. And that's really what I did in order to get that chart to work. So it is a data-driven chart, and then the fields that have been selected in this example kind of just go along with the amount of sea level rise in centimeters for each one of the decadal steps that's in the modeling. So yeah, great question, and that's how we're able to do that.
There's also a question, do you plan to include social capital index?
Do I? I don't, not at this point in time, but if there's someone out there that knows of a data set that we could use to get into Living Atlas, or who to contact in order to do that, I would reach out to them and try to make that available if it's something that the community can use. So please let me know, or drop a name in the chat, or shoot me an email.
All right, so we have Dean in the chat saying to contact Dean. So there's your follow-up. we will try to connect you with the appropriate email.
Perfect.
At this time, we would like to transition to our next speaker, Dr. Tom Allen, who will demonstrate applications of NASA datasets to sea level rise and wetland change for 25 minutes. Dr. Tom Allen is program head of the Sea Level and Climate Institute for Coastal Adaptation and Resilience at ODU. His work specializes in coastal applications of geographic information science, coastal geomorphology and sea level rise, remote sensing, spatial analysis, geovisualization, and coastal hazards, and sustainable environmental systems. Thank you, Tom, for agreeing to share with us today. If you would start your screen share and get started when you're ready.
Yep. Thanks, Nicole. And hello, everyone. Nice to see some familiar faces and probably folks in locations. You know where you are, and you might know me. I'm happy to present some work that I've done over a series of years in projects at Old Dominion and East Carolina University, where I was formerly. So sea level rise is something we know as a major concern to coastal resources with extensive coastal wetlands and their ecosystem services and natural amenities. They come to the forefront of climate change, sea level rise, and coastal subsidence. I have here just a slide from lecture from Sir Charles Lyell at the forefront of geology, basically the father of uniformitarianism, and also catastrophism, which we actually see having roles in coastal evolution largely. At the top of the screen is Mississippi Delta. And so you might have seen this over periods of time, the evolution there, degrading land loss, fragmentation of coastal marshes, and concerns of a coastal squeeze, the potential limitation of the migration of wetlands with sea level rise. I'll be moving quickly. I do have some construction going on around me, but here's a sea level rise projection tool you probably hear further from NASA. We use that a lot in the assessment of sea level rise trends and projections in the future, which we need to inform our coastal adaptation and planning policies and actually projects. So the rate of sea level rise is a concern with regard to coastal marshes, particularly as to whether they can keep up, meaning build upward at or above the rate of sea level rise by accretion of biomass or accretion of sediment, or they will degrade and disappear, either the process of erosion or excess inundation. A number of years ago, students of mine at ECU made this map of the very scary eastern part of North Carolina, most of which is below about 2 or 3 feet of mean sea level, and facing this kind of catastrophic evolution over time. You might see some topography to the kind of left central part of that. That's actually a portion of the Suffolk Scarp, and an escarpment that is a record of prior sea level rise before the Wisconsin glaciation. So we have this concern globally. We're concerned also about deltas in particular, human civilization, environmental and security concerns, human migration, not just wetlands as a result of this. Some places like the Nile and Bangladesh and many other deltas are a major concern. And then some areas we also are seeing mangrove expansion, kind of poleward latitudinal migration or invasion. There are a number of tools that you may also find, not exclusive to NASA. I think I saw Keith's presentation included some data from the NOAA Sea Level Rise Viewer. So they have an extensive collection for the conterminous United States. Then you have the Nature Conservancy, who has some regional products. There's one link there. And finally, recently, Climate Central, the nonprofit, has expanded its products on coastal wetlands at risk. If you want to get kind of a regional sense of tools that are maybe a little more layperson user-friendly than some of the scientific things that I will show you. Another key factor is making informed coastal management decisions requires current and accurate and usable data. And so where are wetlands data found? The primary federal agency for this in US is US Fish and Wildlife Service. They have a product called NWI, the National Wetlands Inventory. Its origins through like the Wetlands Clean Water Act and National Wetland Inventory process was to map wetlands using aerial photography and a very labor manual intensive process. And that has gradually been evolving, but you could see with something like 3,000 quadrangles across the coastal United States, including the Great Lakes, you would have a daunting task ahead of you. A number of other resources we're mentioning that states and some other federal agencies procure mapping of wetlands. And I'm talking mostly coastal wetlands, given our theme. National Estuarine Research Reserves, national estuary programs like the Chesapeake Bay program and some of the others. And then I mentioned TNC, but also the Audubon and Ducks Unlimited do extensive wetland mapping as nonprofits. Some of them have using this commercial satellite data with high, very ultra-fine spatial resolution. And one of the limitations and what got me into this was interest in kind of the ecological geomorphic or landform relationship of coastal wetlands. And NWI is based on a classification scheme that is hierarchical and very structural, but not very species specific. And in coastal marshes, we have a high dependency or need for marsh species zonation data that NWI cannot provide or was limited in its currency of the available dates. Other things such as invasive species, Phragmites being just one of them in some places, caused this, prompted this project that I'll be describing. On the right is a map of some of the coastal quadrangles, the USGS 1 to 24,000, and early intensive study areas that we identified. Here you see another product that's kind of commonly used, the Coastal Change Analysis Program that NOAA runs using a couple year sort of biennial or to 4-year, maybe more recently frequent land use land cover data. But again, limited spatial resolution, limited in being pixel-based classification, and limited in the thematic detail that you would need to say, identify areas of protection or conservation or habitat management. So working on the coast of North Carolina, here's that Phragmites that grows extensively like a colonial type of growth form. It actually is a very rigorous plant that can stabilize a shoreline. On the one hand, there's a little bit of a silver lining to it, but also you can see it displaces valuable habitat of other coastal marshes that would be good to migratory waterfowl and other species. So with Landsat, I've been using this since kind of the dawn of my own research as an undergrad. It started out in 1972 as the Earth Resources Technology Satellite and has been jointly managed by NASA and USGS. So it's one of the longest continuous operating satellite observation platform for environmental applications. You will see this extensively through other online tools and data catalogs, not just NASA and USGS, but NOAA across Google Earth Engine, the Microsoft Planetary Computer, and many others. And through time, its spatial resolution, its ability to observe spectral detail, its spectral resolution, its quantification of remote sensing data, radiometric resolution, and its temporal availability have expanded. So the continuity is a key part to also tracking changes in coastal wetlands. This project, we start out to map initially the South Atlantic from Virginia south through about Georgia. And these are the path row combinations, the World Reference System 2, that shows the particular scenes that we focused on. So of all the thousands or tens of thousands of Landsat scenes available, we filtered those by cloud cover and by tide stage. So we would be mapping the wetlands at a low to maybe mid-tide condition, which is key to kind of accurately mapping and classifying them. Then we worked across these sites to have intensive study areas where we had finer resolution or more thematic, even ground data on the wetlands types. Here we are in South Carolina at the Baruch Marine Institute, run by USC. And then the other improvement that Landsat was allowing us, Landsat 8 particularly, was species-specific zonation data. So here are some transects, kind of a cartoon graphic of the marsh species and zones, the zones being the top level, that we made our objective to map across this latitudinal gradient. And so tidal fresh, brackish, kind of a partially salty marsh, and then key was high and low marsh. Our species in this region are Juncus, our black needle rush, and Spartina alterniflora, so salt meadow, hay, and cordgrass species. And then as you work south to South Carolina, you have a little bit of a variety and shift there. And then further south to Georgia, you actually have a little higher tidal range and you have higher evaporation, so you start to see salt pans. And if we go even further to Florida, you would actually begin to encounter a mangrove zone. So those had to be thematic classes that Landsat could distinguish and accurately map across these gradients. Here's an oblique aerial view showing you some of those conditions at the Baruch Institute, where we have this interspersion and juxtaposition of high and low marsh. And here you are on the ground at the same site, again, showing the importance of collecting at low tide condition, low water level conditions to spectrally isolate and identify the marsh species. And basically our workflow was such as this, where we did an extensive amount of pre-processing. We did this on desktop workstation computers. So we would go to NASA Earth Data Catalog or USGS Earth Explorer, search the archives, filter them by cloud condition, tide stage, and time, and then download the key data sets. Nowadays, I would just in a couple of years' time, I would actually approach this a little differently, which I'll conclude with. But we do scene mosaicing, we do upland masking to reduce potential misclassifications of non-tidal or interior wetlands. We produce composites using image enhanced indices called the normalized difference indices. And then we do object-based image classification. You could do this sort of workflow in Google Earth Engine or using a data cube, or even automating this now in a data science approach with Python and Jupyter notebooks. But we conclude with products and accuracy assessment. Here's some maps of our intensive study areas. We did go up and down the coast collecting imagery, fine scale maps, GPS data, and even drone imagery, and then meeting with local specialists working on these sites. And here's the kind of the heart of the imagery, where we have at the left a multi-spectral composite of Landsat 8. This is also at that Baruch site in South Carolina. And on the right are 3 spectral indices. The Normalized Difference Vegetation Index, or NDVI, the most ubiquitous index there probably is. Then we have Normalized Difference Water Index and Normalized Difference Soil Index. Those 3 parameters capture kind of a multidimensional view of the sediment, moisture characteristics, and vegetative productivity or greenness, biomass, if you will. And you can see the salt marsh zonation extremely well with even a non-contrast enhanced image there on the right. So the proof of concept of this, we had done some trials in North Carolina. We had also done some attempts to prove that you could do this through object-based classification, classifying clumps of pixels rather than individual pixels. So without going into the weeds too much on that, we used an object-based image classification tool known as support vector machines. And at the time, that was and still it probably is, an open source software called Monteverdi. And now if you prefer, one can actually access those algorithms through Esri ArcGIS Pro and using kind of feature-based image classification. On the right is a sample output, and we have the low marsh, high marsh, brackish marsh, tidal marsh, salt pans, mixed or disturbed marsh areas that might include invasives, and then we have even Phragmites where it exists in the Carolinas. Of course, we did accuracy assessment with hundreds of field points and using other local source imagery. We derived an error matrix, calculated kappa indices, and looked at false errors of omission and commission for management purposes. And here are some of the products of that produced. This is actually down near the Georgia Marine Ecosystems LTER site. So it's a highly studied barrier island in the South Georgia coast. And there's our error matrix, though I won't go into too much of the weeds. The magic number seems to be 85%. And we do have some uncertainty that resides in the two varieties of short and tall growth Spartina marshes. And if you actually aggregated those to just Spartina, you would actually bring the accuracy up to about 92%. Those products were then shared, and you can access them on the South Atlantic Landscape Conservation Cooperatives Atlas, and that has also been expanded to include Georgia, at least, Florida, Peninsula Florida. So the Atlantic and Gulf coasts of Florida, north of approximately Orlando in St. Pete, north of the mangrove zone, if you will. And you can access these inputs, the normalized difference indices as raster images. You can access a rasterized version of the classified data and the actually original product vector data in the form of shape files, vector GIS data that you might use with a desktop GIS. Some results of this. Pre-processing is extensive for coastal areas that are very dynamic. So looking to cloud filtering, atmospheric correction. The benefit of using indices in Landsat is that we can now track these through time. I would very much love to do a repeat of this project using more cloud-based image processing and then to track the changes. I'm sure after multiple hurricanes and nor'easters that we've got some changes going on, especially in Florida of recent years. We also have limited training sites. So there's always a need for training data, high quality training data for image classification, especially machine learning like we used. Another limitation is just the variety of the floristics in the compositional species in marshes. Obviously, we can't map down to the single meter through time unless one were to approach this maybe with planet data. But then you're not looking at having the spectral resolution that Landsat has to offer with its middle infrared, near infrared variety. Then you have dynamics of shoreline erosion, wetland disruption or disturbance, such as rack deposition, and finally, things like dredging operations and spoil and just human land cover. Since our project 2 or 3 years ago, a large port facility was built near Charleston, South Carolina, and those are ongoing human dimensions changes that we have to account. Some future approaches, I mentioned looking at invasive species in coastal areas where sea level rise and coastal circulation is a major issue. Dynamic shorelines, I recognize a couple of you on the call have been studying this intensively, looking at shoreline change rates through time and seeing how different marshes are respond to that is a key area. Improving land use, land cover change models so that they actually include marshes, or improving marsh response models, such as the sea level affecting marshes model, or take your pick of other marsh simulation models. We also have some forthcoming data that's very interesting. You may hear about interferometric SAR and vertical land motion data from NASA and ESA and other satellite data that's has potential to monitor marsh erosion or accretion. and then ability to assimilate these data and automate this analysis. I just walked you through 3 years of work on a project, could be done in maybe a season with field data, in the example of using a digital twin approach. Things such as Google Earth Engine or a data cube. Now, I do have some resources that Wendy or George or Nicole or others could share with you. These are for you to kind of look up on your own. I won't assign homework. NASA has done extensive work using synthetic aperture radar for wetlands. There's a lot of wetlands do exist in interior non-coastal areas and continents in cloudy, northern latitudinal or coastal areas. And so SAR can see through the clouds, and you might have a great benefit of looking at that. That story at the top links you to the Alaska Satellite Facility, which is one of NASA's DACs. And there you can actually find some other tools and some cookbook recipes. To do this, there's a really interesting one from Google Earth Engine that some applied sciences folks from NASA have used, where they combine optical and radar imagery. I would love to go into more information about that, but if you work on a finer scale, you may find a great benefit from incorporating Landsat, SAR imagery, and even LiDAR data together to map very fine scale coastal marshes. And then the links at the bottom, I could walk through, but these are the repositories where our product that I walked you through are shared now. So essentially, the Fish and Wildlife Service and the what's called Atlantic Coast Joint Venture now publish these data that you can access and download, or you could probably add them to a map in ArcGIS Online or the Living Atlas. You may even find them there. So that's what I had. I'm welcome any questions and happy to elaborate. I'll turn it back over to Nicole or George.
Thank you, Tom. Yes, if you have questions for Tom, please either put those in the chat or unmute yourself and ask those to Tom directly. A reminder that we will be monitoring the Google Doc, the participant guide today. If you have any questions that we don't get to, we will get those to Tom afterwards. But thank you, Tom, for sharing with us.
I'll break the ice with a little question again, Tom. So, we've been working with GIS data for a long time, and we do these projects that are often regional, and they end up on a regional server or regional web application of some sort, like what you showed with the southeastern marshes. Are there plans to get those data into something like the Living Atlas? I'm always thinking toward like a central repository, and how wonderful that would be if we could have sort of global access to a unified repository for all these regional data sets. Is that a discussion that you've had with others?
Well, actually, the one link there, the long URL that starts with FWS is Fish and Wildlife Service. So the entity that has currently adopted that product has integrated ours South Atlantic and Gulf Coast maps with others from the Mid-Atlantic and New England. And so the good thing is we use a common theme or a classification scheme. So I'm pretty sure it is there for a fact. And the South Atlantic Landscape Conservation Cooperative somewhat ceased to continue its repository, but there's now what's called the South Atlantic Conservation Blueprint. And so the data can be accessed through that. Yeah.
Yeah, thanks for that. It just seems like you're working toward having everything in that repository where if something like you said were to shut down, we could have an existing legacy product that would continue into the future. We think of all the time series studies that are done and how useful those older data are if we can find them, right? So
Yeah, and I have taken specific entities requesting data So I've shared it, through online to conservation organizations, for example. Of course, it's much easier for them to directly discover it and access it through another source. In the interest of some open science, even like our ground truth data or our training site data, we have photographs from hundreds of those locations and GPSs. We don't have elevations, but we have pretty good RTK GPS locations. I think now we would approach this with like a little more integrated products. But I think the greatest part of this is, yes, you have a thematic map and metadata, full metadata, OGC compliant. That's another thing. But you also have the algorithm and the NDX image composites. So that sets it up well for replication and future tracking. Being able to even detect when a wetland is undergoing some degradation.
Okay, thanks, Tom. I don't want to
I
monopolize.
see a question.
I'll turn it over to somebody else.
If I have another minute or two.
Before you get to that question, let me just remind our participants that we do have a reflection activity that we're asking for them to participate in. I see some have already added comments after your presentation. Blake is going to post this link in the chat for you. So while Tom gets through the rest of his questions, please see if you can come in here and share some of your thoughts about this presentation. I'm going to take this down, Tom, so that you can answer that question in the chat.
Okay, so Chen has asked a difficult question. My short answer is no. However,
Hey, Tom, could you restate the question for
the
those?
question is, what other NASA data can be used instead of Landsat? And so more accurately or at higher resolution? Not really, no. I don't say that too pessimistically, but however, to augment it, yes. Like for example, the Phragmites spectrally is a super challenging species of marsh to differentiate. But if you add a synthetic aperture radar data set to that, the vegetation structure is very responsive. So this kind of multi-sensor image classification becomes very helpful in that case. So that's, I didn't go into details of that, but one could obtain a SAR image like ALOS Pulsar, Sentinel-1 from ESA, or maybe even now you have Capella Space, a commercial vendor for SAR imagery, and then the future NISAR. There's another question from Marin. Thoughts on using Landsat and the methods to delineating degraded salt marsh? Yes. What I would look for, in fact, those NDX imagery, there's a paper I kind of cited there by Kearney and Rogers, who came up with the NDX composites. It's basically similar to something called the tasseled cap indices, trying to capture data compression, like a wide variety of spectral variation with just a few indices. I would be looking at that to calculate NDX images through time, and then look for spectral changes like a change in the NDVI index, a change in the water index. And you actually would be able to see those shifts in the spectral indices before you would necessarily classify a shift in the thematic class of a wetland. And there was another approach to that, is to classify the NDX images into what's called marsh condition indices. So you might see some work by Brad Couvillon and some others in the Mississippi area, and Greg Kearney, a number of others in the Chesapeake Bay have been trying to do that.
Thank
Hopefully
you,
that helps.
Tom. I just want to remind our participants that we do have a space for reflection for you. That link has already been posted in the chat. We have a 5-minute break at this time before our next set of speakers. So please engage with the reflection document during the break and get up and move around. And we will see you back at 11:05 for our next set of speakers. Thank you.
Are you still muted, Nicole?
Thanks. I have 11:05, so we're going to go ahead and get started in an interest of staying on time and being respectful of everybody's time. A quick reminder, if you have the participant guide open, and we encourage you to have that open all day, that we would ask you to please sign in if you haven't had a chance to already. And at this time, I would like to introduce Doctors Ben Hamlington and Carmen Blackwood, who will be sharing about NASA science on sea level rise for 30 minutes total. Dr. Ben Hamlington is a research scientist in the Sea Level and Ice Group in the Earth Sciences section. He studies the ocean with a particular focus on sea level variability on interannual to decadal timescales. Ben is the team lead of the NASA Sea Level Change team, and we are proud to say a former member of the oceanography faculty at Old Dominion University. Dr. Carmen Blackwood is a physical oceanographer at the Jet Propulsion Laboratory in Pasadena, California. Her sea level change research focuses on the interactions among the atmosphere, ocean, land hydrology, and land ice. If you two would please start your screen share and go on with your presentation when you are ready.
Sounds good. I will share my screen first. So I'm actually at a hotel in France right now at a conference. So I'll probably turn off my video as I present, but just wanted to turn on briefly to say hello. Let me start sharing. 1 second. Okay, so I know we only have 30 minutes, and I really want to leave the bulk of the time for Carmen to go through some of the tools that we have. And I just want to introduce the NASA Sea Level Change team and some of the work we're doing and the approach that NASA is taking to sea level rise. So the title here is NASA Sea Level Science, Supporting Planning and Adaptation. My main focus is really on the work of the NASA Sea Level Change team and what we're doing. But to kind of orient us, Tom and Keith had already talked a lot about some of the satellites that we use, some of the information we use. That's really the foundation of what we do in terms of sea level at NASA. We have really powerful instruments to measure sea level. We have this constellation of satellites that measures not only sea level change itself, but also some of the processes that contribute to sea level change. So I'm just showing 3 of those here. The Sentinel-6A Michael Freilich is the latest in a generation of satellite altimeters, which measure sea surface height. We call it a long track, so you can see it's measuring the height of the ocean directly below it as it orbits the Earth. We now have a 30-year record, a continuous 30-year record of this satellite altimetry. We have the GRACE and GRACE follow-on satellites. These go back to 2002, extending up to the launch of GRACE follow-on just a couple years ago. So with this, we can track ice mass loss from the ice sheets. We can track the movement of water around the Earth from land to ocean. So again, a really powerful tool as we think about what's causing sea level. And then the most recent is the Surface Water and Ocean Topography mission, the SWOT mission, which launched just last year, and we're just starting to get some of the initial data returns. I'm going to talk about that in the next slide for just a minute. It's a little bit of advertisement for our latest tool. But from there, we take those observations and we can do a lot of different types of analysis with them, and we really try to transition that into something that is ultimately useful. And that could be useful in the sense of contributing to reports. So Keith mentioned that interagency report, which NASA contributed heavily to, but it could also be just providing tools or access to the information, which is what Carmen's going to cover in detail. But that's really where the NASA Sea Level Change team comes in. So I'm going to focus on that in a couple slides. As I mentioned, I did want to talk briefly about the SWOT satellites. So actually the reason I'm in France is for a SWOT science team meeting. The nice thing about SWOT is that it is making a new type of observation that gets us closer to the coast than ever before. So it measures water not just over the ocean, but also on land and also at the interface between land and ocean. So in terms of our ability to provide good information for sea level change that's happening at the coast, SWOT really is, I think, a game changer for us in terms of what we're looking at. And just to show that in one other way, so you can see in that lower right, this is just a simulation. I'm not able to show any real data yet until it becomes publicly available, but it measures in a 2D swath, unlike those other altimeters that I showed you that measure a long track. And the benefit of that is that we get really high resolution estimates of sea level over the ocean, so down to 10 kilometers and up to a couple hundred meters away from the coast. It also measures rivers and lakes. So rivers that are about 20 meters in width or wider, SWAT's going to measure the height of the water in those as well. So this is just a little advertisement for SWAT. Though I think there'll be a lot of tools available to users who want to explore this data set, which is going to be coming online in the next couple months. Okay. So back to the sea level change team. So within NASA, we like this new pyramid that's the data, information, knowledge, and wisdom pyramid. You may have seen a version of this. They're all over the place. But within the sea level program at NASA, we have kind of constructed our own version of this, where at the foundation we have our science, like that being done by the NASA sea level change team. We have our observations, our modeling, the projections and predictions we do on top of those observations and models. And then we work with different partners. So either boundary organizations, different agencies, and we really have two different flows. So we work at the national level with, say, NOAA, USGS, the Army Corps, and basically any of those agencies, as well as more local entities and states. On the international level, we work with the United Nations, the World Bank, the Department of State, the military. So really trying to use our foundational information and put it into these different workflows and work with those who ultimately connect to the end users. So I think an important thing to note here is that our goal is not necessarily within NASA science to go directly to the end user. It's to support partners to kind of help with that transition. And I do want to note that one thing that we really get value from is that we get information back from the end users and the stakeholders about how to better target our research and how to maybe create new satellites that could fill data gaps and needs. All right, so the NASA Sea Level Change team, it started in 2014. We're now in our third iteration. I've been team lead since 2017 and will be through 2028, so through the next iteration. We actually have a call out for the next formation of the next team coming up in October. So it is a competitively selected team within NASA. We have about over 80 scientists across federal agencies and academia here in the US that make up the NASA Sea Level Change team. And our objectives are really to try to understand the drivers of sea level in the present, transition that to projections into the future, and then ultimately deliver that improved understanding to partners and stakeholders. Our public face, our web portal is sealevel.nasa.gov. That's what Carmen is going to talk in detail about. Just to note here, the Sea Level Change team is made up of individual investigations. I don't expect you to read all of those, but these are the individual investigations that cover the breadth of the work being done on the Sea Level Change team. We have a bunch of different PIs, so we kind of have a team of PIs that sit underneath the overall structure of the NASA Sea Level Change team, and each of these individual investigations has a number of scientists on them as well, and grad students and postdocs. And then Carmen is the PI of the web portal, and she'll talk to you in just a minute. But what's kind of unique here within this is a little bit of an unusual setup within NASA, and I think we're a little bit of a pioneer in terms of what NASA does. First of all, we are kind of building in this approach to transitioning science and observations into actionable information all into one team. So a lot of times within NASA, these things get kind of sectioned off from each other, where you have the science living in one area, then the application, and then that ultimate transition into actionable information sitting in another element. Here, we're fully integrated into one team. We've also taken an additional step and formed what we call a practitioner consultation board of 20 sea level practitioners from across the US. So they really help us in co-development, understanding what's needed. So the tools that Carmen's going to show you, I'm just showing screenshots there at the bottom, those were all co-developed with feedback from those practitioners. So again, it's something very unusual for NASA to kind of engage in that kind of process. But I think it's something that is highly beneficial to the work that we're doing. And then we also have an outlet and a public face to deliver information and support action. Again, that's a little bit unusual in terms of NASA science teams, but we have this direct connection to sealevel.nasa.gov. All right, just two more slides here, and then I'll hand it over to Carmen. So yeah, just to note, the practitioner consultation board, that's a list of people there on the right. We tried to get a pretty good geographical distribution around the US coastlines. They are from other federal agencies, but also from cities and states, from sea grant programs. So really people who kind of have their finger on the pulse of what's needed by end users and have a good understanding of the science such that they can work in that interface between the work that NASA does and their end users. And we do whole workshops. We have regular meetings with this group. So it is a very active group and something we really rely on. All right, and my handoff to Carmen. I just want to note that we have a range of tools, and we are consistently trying to improve upon those. So we partner with the IPCC to deliver the projections from the sixth assessment report, the interagency report. A lot of our NASA scientists contributed to that report. We also then created a delivery tool for that, and then more recently the flooding analysis tool. So we're in this constant mode of updating these tools, getting user feedback. There's ongoing support from NASA. And I will let Carmen take it away with a little more details on these tools and what the portal is doing.
Thank you very much, Ben. Yes, so let me share my slides here real quick. Does that show up okay? Okay, very good. All right, thanks, Ben. And also I wanted to thank Wendy and George for having us here today to present some of our work. As Ben was saying, I'm the PI of the NASA Sea Level Change portal at sealevel.nasa.gov. But since 2014, since we started developing the portal, we have worked with a big team at JPL and also at Moorbeck, which is a web design company that we're working closely with that has a lot of experience working with NASA projects that is helping us with the overall web design as well as developing some of the tools that I will be talking about. And also I want to give a shout out to Pat Brennan and Holly Shaftel, who are working closely with us to highlight any news that are coming out of the science team. So as Ben said, we exist since about 2014. And he mentioned or alluded to some of the interdisciplinary aspects that sea level change has. So in the beginning of this project, we were focused more on bringing the different science areas together, like oceanography connected to cryospheric science, connected to solid earth science. And as the team got more established and we're now working closely together between these interdisciplinary areas, we are focusing now more, as Ben was also saying, more on providing actionable information. And this is how some of these tools have been developed in close collaboration with our practitioner board. So really what we have now is hopefully a one-stop source for scientists, the public, and decision makers to look at what NASA can provide in terms of sea level information and data, some of the latest news and publications that are getting translated into news articles that Pat is putting together for us. And then we have some interactive tools for analyzing and viewing the data, and I'll get to that in a little bit. And of course, we try to make this work on several different platforms. It is mobile friendly, so if you want to try to access the site and also the tools on your phone, you should be able to do that quite seamlessly and work with everything that's on the portal on your phone or tablet, for example. As mentioned, we're publishing news on any kind of NASA research that is coming out with regards to sea level. We have several different formats you might be interested in looking into. We have news briefs that come out a little bit more frequently. These are science highlights explaining the latest findings in a more compact format. Then we have more extensive sea level news, which are articles featuring the latest highlights from the NASA Sea Level Change team. And then we also go into depth with some of the scientists of the team and provide some in-depth interviews, which might be interesting to look at for diving more deeply into what we're doing at NASA. So the homepage of the site should give you hopefully a nice overview of what we're observing. Ben mentioned the different sensors, and here we try to summarize some of what we're seeing in terms of global mean sea level, how the changes in ocean mass are contributing to that, how changes in Greenland and Antarctica are contributing to that. And with these graphs, you have an interactive view of what the data is showing us. Then we have a section called Understanding Sea Level, which is more of the background information on why sea level is rising, how do we know that, how can we interpret the different satellite measurements that we get for the global ocean, but also contributions from the ice sheets, from land hydrology, and the solid earth. And then we have a resource section where if you want to get a nice graphical representation of what the data is showing, there's some resources there. Here, for example, we show an image of the altimeter data starting in 1993 and going up to more recently, now 2022, 2023. And then you can look at other animations too that allude to some of the changes that are happening in the Antarctic, for example, or in Greenland. And then speaking about the tools in a little bit more detail, as I said, we started off with looking more at the science applications, and we developed a tool where you can explore the different data sets that we have and look regionally at what is happening over time. So here we're seeing some of the data, and you basically can look at any part of the ocean and plot a time series and run an animation, and you also get some of the metadata that is behind all these different data sets. But then we already heard some of the applications of the sea level projection tool. This is a very prominent tool now on the sea level portal that gets used a lot. So this is also, as Ben said, an access point to the information that the IPCC report provides. The IPCC report is a big document, so we've been working closely with the IPCC team to provide the information in a condensed form and more visually accessible form through these tools. And as you can see, we have some of the regional data provided over the ocean. You can flip between total sea level and ocean mass, but then you can also look at specific locations and see what the projections are saying. And you can also switch between the scenarios and the associated warming levels, which might be easier to interpret. So, and then, yeah, we go into detail also what are the different contributions, and you can swap between different time periods to look at the different contributions here. And then another tool that we're providing where it's more about the data that we're observing from the different sensors, like the altimetry and the GRACE and GRACE follow-on time series of ice and the water cycle, as well as ocean mass and the changes that are happening due to thermal variations. And again, this looks very similar, but here we provide an overview of what the data is showing us in comparison to some of the tide gauges that are distributed along the coastline all over the world. And this is a tool to dive more deeply into what the different measurements are saying and what the different contributions are. So in some areas, the ocean dynamics might be of more importance. In some areas, it might be more the ice and the water cycle. And this is just quickly the interagency tool that provides the interagency data. Again, very similar in the layout and usage. But if you want to dive in more deeply into these interagency projections, which are in some ways a different interpretation of the IPCC outputs, this is the tool to go to. And then we're also working with PIs directly. Ben showed this already, to provide some of the data that they're producing. And this is a tool where you can look at flooding days and projected flooding days into the future. And just very quickly, if you want to work with the data directly through code, there is a possibility to interact with the data directly through Python, for example, MATLAB. There's interfaces that are provided where all of the data that are provided in these tools can be accessed. And with that, I would like to encourage you to check out our webpage at sealevel.nasa.gov and check out our content, look at our tools, and give us any feedback if you have. Thank you.
Thank you, Carmen. And we do have some time for a question and answer period with Carmen. And I think Ben is still here if you have questions for Ben as well. And you can put those in the chat, or you can unmute yourself and ask those directly.
Carmen, I have a quick question. Yeah, so my question is like the tools you have mentioned and Ben mentioned also. So my question is like, are these tools applicable to global scale, like any other locations, globally, or only in the US?
So both the IPCC tool as well as the C tool, as we call it, sea level evaluation tool that looks at some of the data do have global data and also provide the information at global tide gauge locations. The interagency tool, because of its nature, is focused more on the US.
I was just going to add the flooding analysis tool. We are in the process of transitioning that to international as well. So I think more and more we'll try to provide we're trying to consolidate. So one thing is we don't want too many tools. I don't think anybody wants more tools. So we're going to try to consolidate a little bit and shift towards international focus where possible. So with our NASA data, we should be able to provide global scope. So that's really the goal.
Thanks so much.
I have a couple questions in the chat too.
Yeah, I saw one, and then Carmen, you can take the other two. Is there any sample SWOT data available? The answer is no, not yet, unfortunately. I can attest to the fact that the data looks extremely promising and looks good. I think it's overperforming specifications, but the data will not be publicly available until later this year. So look out for something in November.
And I'm sure we're going to have a public announcement on the portal about that as well. So if you monitor that, you should be able to see that. I saw the question about R. I think that should be able to access it too, like any kind of coding language you could use should get there. With the question about access via REST endpoint, OGC, WMS, I kind of want to hand it off to Bergen or Na, who I think I've seen on the call.
Na's here. She should take that. Otherwise, I can.
I can take that one, Carmen. Thank you.
So
yes, we do have Jupyter notebooks that are Python based and can show you how to access those REST endpoints, but they are available, and we would see someone contribute to in our example. Oh, can
Can
you
we
still
share
hear
a
me?
link too?
Yes, we can share a link. Yes.
Yeah.
All right. Did we cover this last question about the link? Is that what you guys were just referring to?
Yeah, I think now might be able to post a link in the chat.
Yes, we'll.
Okay.
So I want to encourage you all to think about additional questions for them. I also want to remind you that, like after every presenter, we do have a requested reflection activity for you. So some of you are still in or just joined this document. Blake has posted the link in the chat again for you. This is the same link you were in earlier for our other presenters. So if you will just click in here, double click wherever it is that you want to add your comment, and please reflect on Ben and Carmen's presentations for us. We would appreciate that. Also a reminder that if you have any questions that we don't get to or you think of later, we will get those over to our presenters. You can put those in the Google Doc, which we are monitoring. All right. While you all continue to comment in our reflection document, I want to thank Ben and Carmen again for joining us today and providing this great presentation. And I'm going to transition us over to our next portion of the workshop. So we're on to our exploration portion of the workshop. All right. So for this, you're going to be in breakout rooms. Sessions will be recorded and notes will be taken during discussions. Comments will not be attributed to any one person in any of the products distributed after these workshops take place. We will remove your names from any of those. A quick introduction to the purpose of the upcoming breakout exercises will provide participants the opportunity to discover NASA datasets through collaboration with one another. Introductions for the exercise are included in the shared document. An UNBOUND team member will be in each room for support. In this exercise, your team will search for a particular data set. You will choose one person to act as the driver, one person to act as the navigator, and one person to act as the observer. The navigator will provide directions to the driver, who will take the wheel via the mouse and keyboard and follow the navigator's instructions as the pair attempt to locate the data set. The activity is most helpful with frequent communication between navigator, driver, and the rest of the participants as you go along. The observer will take notes and summarize the insights for the group. When we return to the main session, you will have a couple minutes this time instead of the very brief 1 minute that you had yesterday. The observer will focus on how the information was accessed and highlight any sticking points encountered. These breakout rooms are a little bit longer. They will be 30 minutes. You will have 5 minutes to choose roles and 25 minutes to find the information. This room that you're in right now will continue to have someone here if you need it. Otherwise, we ask that you please follow the links provided to the assigned breakout room. Remember, your assignments are in the participant guide. If you don't remember which room you should be in, please go there and take a look. And Blake is posting the links now for you to access the breakout rooms. We tried to make it a little bit easier than it was yesterday, by creating some tiny URLs for you. If, however, you were perfectly comfortable with the way you did it yesterday, you can still go back to that main landing page and access them from there, whichever way works. So thank you, and we look forward to seeing you in breakout rooms in just a few seconds. All right, I want to thank you all for commenting in here and mention that this will stay open to you so you can keep commenting. But for the sake of time, we are going to go on to our report outs. Since last time we went in usual numeric order, we're going to switch it up this time and start from the back. So group 5, would your observer be willing to report out for 2 minutes on how your exercises went? So some successes that you had, some challenges that you might have experienced.
Yeah, so I'll go ahead and give the report. So our question pertains to flooding days per month on a 5-year average located in Sandy Hook by the year 2050. So we originally searched flood data NOAA on Google, and at first we weren't exactly sure what we were trying to look for. But the second site down, or maybe the third site down, we pivoted to the sealevel.nasa.gov site. And after a few minutes of browsing on the homepage, we found that they have a flooding analysis tool. So we launched the tool, looked up Sandy Hook in the location tab, and we hovered over to the plot estimate for the flooding days per month. At first, this didn't really give us what we wanted. We were kind of looking at a plot that gave data for flooding days, but not for 5-year averages by the year that we wanted. So then we pivoted to the Atlas ARC GIS maps and the Living Atlas, I should say, and searched again, flood NOAA to see if we could find some results. We started looking at a map of high tide flooding probability scenarios through 2100. Again, located Sandy Hook, and adjusted the time slider to 2050 for the year. We struggled to find the data specifics. It didn't give us, again, the 5-year average per month. So we started looking at various tabs and tools in the window. Ultimately, the site didn't give us what we wanted. So we pivoted back to the sealevel.nasa.gov site. And Zach, with great communication, pointed out that the answer was kind of right in our face from the get-go. Yeah, I would say overall, we worked off of instinct, and we were able to find the results very quickly. The biggest, I guess, struggle that we had was at first deciding which, I guess, tool to look for to exactly answer the question.
Okay, great. Thank you. We appreciate that report out. Group 4, is your observer available to provide a report out of your successes and challenges?
Yes, we found today's exercises to be a lot less challenging than yesterday's. We found for the first one that the flood analysis tool was very easy to locate and navigate at the Sea Level NASA site. The presentation was very useful having that before trying to do this one. And the website was easy and simple to find. Location to navigate was easily located. However, one member did state that the other locations besides Sandy Hook, if you have another location that you're looking for, are not as easy to find in the tool based on his previous use of the program. The flood days projection tool would be useful in helping develop for my community our land use plan and determining which areas of our community should not be prioritized for development potentials. And for the second exercise, we found the tool was easy to find and straightforward. You would need to know where the location is in order to find it on the map that's provided. There was a little confusion using the scenario setting from the main page versus the zoomed in location. And we weren't sure if that was the only data, if there was only data for certain locations, or if it was an issue with the navigator's computer. The sea level rise prediction tool is global, which is appreciated, whereas the flooding analysis tool is only for the US, and the map does not capture boundaries or footprints for a certain community or geographical boundary, which would be helpful to have. We had a lot more difficulty with the third exercise and finding which tool to use. And we ended up just Googling the question like a lot of students do, and found the sealevelnasa.gov site and why seas are rising faster on the southeast coast. And then we used a hot link in that information for stereodynamic sea level rise to find the answer to the question. So there were great subcategories there to help us understand all the aspects that go into the data and the analysis. I think that kind of captures most of what we talked about.
Great, thank you. Group 3, is your observer available to share your experiences?
That would be me. I was having a little trouble with my my mic earlier. Can everybody hear me okay? Okay, all right. Speak up just in case. So I would say, so the answer to the first question, we all had the same questions, I'm assuming, about how hard was it to find the tool. Well, our navigator, or was it our navigator or our searcher or whatever, he had already found it and bookmarked it, so he had actually opened up on that page, so we got a little bit lucky. But once we found the tool, it seemed really easy to navigate, and we're pretty fast results there. The only thing that came up, I think, was and it really wasn't a big deal, but the intermediate, the way it referenced the time frame, we were wondering at first if that really covered our 2080 or whatever we were looking for. But then we realized in the graph below that we could just pick it out ourselves. So I don't know if I explained that very well. In terms of how the information in the tool, in the flood days projection tool, will be useful to all of us. Kyle said it was found very useful in his work because a lot of the things that he uses are disaggregated, and he has to pull them together, and there's a lot more in one place than what he usually sees. And I know, Grace, you said that the variables could be really useful. There's a lot of ways of customizing the data. And then, we talked about other sources of data used for sea level rise in our work. And I know for myself, having standardized data, and I realized that through NASA IPCC data was available. And from my perspective, I work globally, and having standardized data is really important and hard to find. So I'm trying to go with the most standardized information. For exercise 2, the navigating was fairly smooth, but then we were surprised that the link on the gauge took us away from the map, and then we had to go back again, and then we lost our spot, so we had to search for it. So that's like a little pet peeve of mine. When you lose your spot, it's just frustrating. And then finding the tool, it was easy to find, but one of the things we noticed is if we did like the flooding versus the sea level rise, the time frames on the scenarios are slightly different, and we didn't know why. There was an explanation for that, so that might be interesting to look into. I think it's fine when there are differences, so long as it's explained. And then would it be George asked us if it would be useful to go out more than 100 years, and all of us said not really. And then in terms of the article search, we'd all probably most likely use Google rather than start on a NASA page, but it happened to flash by us while we were looking for it on the top banner, and so we just clicked on it and it was right there. So that was really easy. Would we use these tools? So the other two said that they would. I'd be more likely to use the data behind it, so for what that's worth.
Thank you so much. Sure. Group 2, is your observer available to provide a report out?
Y'all, I'm Group 2's observer. So we started with the first question by Googling interagency sea level rise scenario tool. zooming in on the East Coast, but eventually figuring out that wasn't the tab that we needed. And we clarified with the question and then Googled sea level rise NASA, clicking the sea level change website and Googling assessments. And we still didn't feel like we were finding what we were looking for. So we Googled NASA sea level sea level change analysis, and then clicked the flooding analysis tool. And then we were from there able to enter Sandy Hook, New Jersey, and changing like NOAA moderate and trying to figure out a 5-year average. We felt like we found the tool fairly easily, but we had difficulty when we were on the page trying to like both dissect what was asked in the question and what we were seeing on the page. Trying to figure out like what exactly do we need, which graphs do we need, and what exactly are those graphs saying, kind of thing. We did eventually reach the answer, and we started question 2, which we had a lot more ease with because we recognized that it should start in the same tool that we had been using. And like the team blew through that in just a couple minutes, finding all of the answers, navigating with the tool that we just spent time working with. But yeah, some things that went well, we found that we were able to find the tools easier, but we had a little bit of difficulty on the first question with figuring out exactly what data to use and where to find that kind of data on the site.
Great. Thank you. All right, we are at 12:30. And so in the interest of those of you who need to go on time, I need to just let you know that there is homework associated with our work from the past couple of days, and that homework will be shared with you via email. So our purpose from today was to introduce you to resources available from NASA to examine sea level rise and other flooding issues within your communities. Your activities in your homework will have to do with NASA sea level change teams, flooding resources, and NASA Earth data. So we're asking you to work through the steps, and then once you have found the data, please give us feedback on the overall process. And so again, that'll be in the email. Also, the participant guide is a wonderful resource for you to add any remaining questions. I do want to hear from our group 1 reporter before we go. So again, I will try to make sure that I do not keep you more than 5 minutes over for any session. Is our observer for group 1 available?
Hi, yeah, that's me. So I think we had a largely similar experience to the other groups once we got to the Sea Level Rise NASA homepage. Just clicking through the tools that are already linked there was pretty straightforward. We went through a couple different ones at times and then landed on the right one and found it fairly easy to navigate and figure out the different like intermediate, moderate scenario levels. Always a little bit of clicking when it's your first time using something, but for the most part, found it straightforward. And we had the same experience where we were just looking on the homepage and the article kind of flashed across and we were like, oh, that's what we need. But we found that helpful as well. I think we all found that we could see ourselves using these tools, but our main question was how we would be able to extrapolate that data beyond the points that we searched, like Sandy Hook or, the seawall point, like is the data that's being shown there, like how wide of an area does that cover, like where are the differences there, because not every point that someone might want is on the map, obviously. So that was kind of our biggest question for the first 2 activities. And the second one, we thought it was a great article. I do a lot of stuff like that with the Park Service, so it's always great to see that kind of communication, but it would have been nice to have some links to the actual data that might have been used. I think that it was nice to have those summaries and the extra like terms to find, but to be able to click and see, here's the data set that we used to determine that, I think might have been helpful for people who are really like not just looking to answer the question, but like dive deeper into that topic. So I think those were our main thoughts, but overall, yeah.
Awesome. Thank you so much. I appreciate it. All right. So before you go, reminder, you will have homework in the follow-up email. Like yesterday, you will get a follow-up email. It will have the resources that were shared today, as well as the homework. And we want to thank both our funder again, as well as you all for your time. And so just a reminder that our funding is from NASA Earth Science Division. The Unbound for Coastal Issues multi-session workshop is supported by the Understanding Needs to Broaden Outside Use of NASA Data project. And we want to extend an offer to you. If you haven't yet been able to arrange to receive the continuing education credits, please let us know. But again, thank you all for your time and patience with us, and we look forward to seeing you next week.
Thank you all. See you next Monday.